Hello, St. Italians! Good day! Welcome back to SMAPI Mathematics Club video channel, the education and tutorial video program in the field of mathematics in junior high school. And this video, we are talking about the divisibility rules, a preparation for your basic mathematics lesson in grade 7 and grade 8 on first quarter, which applies the basic concepts of arithmetic and factoring. Before you watch this video, you can follow and subscribe our YouTube channel of the SMAPI Mathematics Club below. And if you like to watch our educational video on Facebook, you can follow and like the Facebook page of the SMAPI Mathematics Club in the given link at www.facebook.com/SMAPI-Math-Club. Let us start and learn more mathematics. Students, are you familiar with divisibility rules? Alright, so today we will discuss about the divisibility rules. What is divisibility rule? A divisibility rule is a shorthand way of determining whether a given integer or number is divisible by a fixed divisor without performing the division, usually by examining its digits. It can be easily tested if one number can be exactly divided by another number. These rules let you test if one number is divisible by another without having to do much calculation. Meaning to say, there is no need to check using a calculator if the given number is divided by their own divisibility without the remainder. Speaking of divisible by means when you divide one number by another result is a whole number. Students, historically speaking, the divisibility rules was introduced in the year 1968 by an American author, Martin Gardner. Who is Martin Gardner? Martin Gardner was an American popular mathematics and popular science writer with interests also encompassing the scientific skepticism, micromagic, philosophy, religion, and literature. He had a lifelong interest in magic and illusion, and it was regarded as one of the most important magicians of the 20th century. He was considered the Dian of the American cosmos. He was a prolific and versatile author, publishing more than 100 books. Gardner was best known for creating and sustaining interest in recreational mathematics, and by extension, mathematics in general throughout the latter half of the 20th century, principally through his mathematical games, columns which includes the divisibility rules. These appeared for 25 years in Scientific American and his subsequent books by collecting them. Students, today, let us differentiate these divisibility rules, and I will give you some of the following examples and its counterexamples. Let us start with the divisibility rule of 1. Divisibility rule for 1 means that every number or integer is divisible by 1, which the rule has no specified condition, so no rules are needed. For example, number 3. 3 is divisible by 1. So there is no specific condition. Another example is 372. 372 is also divisible by 1. How about 4,573,372? Is that number divisible by 1? Yes, of course. This number is also divisible by 1. Okay, students, our next divisibility tool, which is 2. Divisibility rule for 2 is a number which ends with an even number, meaning to say the last digit must be an even number like 2, 4, 6, 8, and 0. For example, 728. So let's go back to the definition of the divisibility rule for 2. A number which ends with an even number. Meaning to say, the last digit must be an even number also. So what is the last digit in a given number? Alright, so the last digit is 8. So 8 is the last digit of the given number. Question, is that the number 8 is an even number? Yes. So 8 is an even number, therefore 728 is divisible by 2. Did you got it? Another example, 3,456. What is the last digit in a given number? Alright, so the last digit in a given number is 6. Is that a last digit is an even number? Yes, of course, this is correct. So 6 is an even number, therefore 3,456 is also divisible by 2. How about 343,243? What is the last digit in a given number? The last digit is 3. So, is that the last digit of the given number is an even number? So, the correct answer is no. So, 343,243 is not divisible by 2. Some of the given examples mentioned on the board are all even numbers except in the last given example. Thus, all even numbers are divisible by 2. Did you got it, students? Students, let us discuss about the divisibility rule for 3. Divisibility rule for 3. The sum of the digits in a given number should be divisible by 3. Meaning to say, the result when the sum of these digits must be 3, 6, or 9. That satisfy this condition, which is divisibility by 3. This is an easy method to find numbers which is divisible by 3. For example, 3,789. So again, divisibility rule for 3, the sum of all digits in the given number should be divisible by 3. So what we're going to do is, we have to chunk all of these digits. We have 3, 7, 8, and 9. Then we have to add all together. So 3 plus 7 equals 10. 10 plus 8 is equal to 15. 15 plus 9 is equal to 24. So, do you think 24 is divisible by 3? So, if you want to prove that 24 is divisible by 3, so let us repeat this process again. So, 24, you have to chunk all the digits, becomes 2 plus 4. So 2 plus 4 is also equal to 6. Thus, 6 is divisible by 3. And then, 3,789 is also divisible by 3. So that it is. Another example is 54,171. So let us do the same procedure. So let us chunk all of these digits. We have 5, or it can be used mental, or it can be solved mentally. So 5 plus 4 is equal to 9. 9 plus 1 is equal to 10. 10 plus 7 is equal to 17. 17 plus 1 is equal to 18. So the sum of all digits of this given number is 18. So 18 is divisible by 3. So if you want to prove that, let's do it the same rule. So 1 plus 8 is also equal to 9. So 9 is divisible by 3. Yes, of course. Therefore, 54,171 is divisible by 3. Last example, we have 43,266,700 737. So, let us do it the same procedure. So, you can also use to find the sum of all digits mentally. So, 4 plus 3 is equal to 7. 7 plus 2 equals 9. 9 plus 6 equals 15. Plus 6 equals 21. Plus 7 equals 28. Plus 3 equals 31. 31 plus 7 is equal to 38. So, do you think 38 is divisible by 3? If you don't sure, let us prove it. So, 3 plus 8 is equal to 11. So, repeat this process again. So, 11. So, 1 plus 1 equals 2. Is that 2 is divisible by 3? Of course not. So, 2 is not divisible by 3. Therefore, the given number is not divisible by 3. Did you got it? Divisibility rule for 4. The number formed by last 2 digits in a given number must be divisible by 4. For example, 724. What are the last 2 digits in a given number? The last 2 digits are 2 and 4, so that is 24. So 24 is divisible by 4. If you like it to prove that, so you can also use the long division. So 24 is divided by 4 is equal to 6. We notice that the quotient is no remainder. So 24 is divisible by 4. Therefore, 724 is also divisible by 4. Next example is 237,456. So what is the last 2 digits in a given number? Right. So the answer is 56. So the last 2 digits is 56. Can you prove that the 56 is divisible by 4? So we will do it with the long division process. So that is 56 divided by 4. So if you like it to prove that, so 5 divided by 4 is 1. 1 multiplied by 4 is equal to 4. So 5 subtract 4 is 1. So next digit, bring down 6. 16 divided by 4. So 4 times 4, 16 is equal to 0. Therefore, the remainder is 0. If the remainder is 0, then 16 or 56 is divisible by 4. Therefore, the given number 237,456 is also divisible by 4. Last example, 674,235,642. What is the last 2 digits in the given number? So the last 2 digits is 42. So 42 is divisible by 4. So we will use again using the long division. We have 42 divided by 4. So 4 divided by 4 is 1 times 4 is 4 equals 0. So bring down 2. So 2 divided by 4 is 3. So the remainder must be 2. So therefore it is not divisible by 4. Therefore, this given number is not divisible by 4. Next, students, let us discuss the divisibility rule for 5. When we say divisibility rule for 5 is a number which ends with 0 or 5. So we can simply determine the numbers which are divisible by 5. For example, 7,485. So, question students, is that a given number which ends with 0 or 5? Of course, yes. So, the last digit appears with 5. Therefore, this number is divisible by 5. Another example, 42,340. Is that a given number? 42,340 is divisible by 5? Yes. Why? Because the last digit given there is which ends with 0. Therefore, this number is also divisible by 5. How about 675,564? you think, students? Is that divisible by 5? Of course, it is not divisible by 5. Why? Because this number which ends with 4. But 4 is not end with 5 or 0. Therefore, this number is not divisible by 5. Did you get it, students? Okay, students, let us discuss another rule for divisibility, which is 6. This is a number must be divisible by 2 and by 3. Why? Because 2 and 3 are the prime numbers of 6. And this rule must satisfy both conditions whose number is divisible by 2 and divisible by 3. Meaning to say, we need to prove that by using divisibility rules of 2 and 3. For example, 1,536. So 1,536 we need to test using the divisibility rules of 6. So let's try to use divisibility rule for 2. So divisibility rules for 2, 1,536. So again, divisibility by 2, which ends by the given even number. So is there a last digit in the given number? Yes. So the last digit is a given number, which is 6. Then it satisfies this condition is a divisibility by 2. So this is correct. How about divisibility by 3? So again, so when we say divisibility by 3, whose the sum of all digits is also divisible by 3. So we need to prove that 1,536 is divisible by 3 by adding all of these digits. So 1 plus 5 equals 6. 6 plus 3 equals 9. 9 plus 6 equals 15. So whose sum is also 15. So we need to check that 15 is divisible by 3. So 1 plus 5 is equal to 6. Thus 6 is divisible by 3. So we have it divisible by 3. So they are both that satisfy these conditions. Therefore, 1,536 is divisible by 6. Did you get it? How about the last example? 567,423. So, we need to prove 567,423 using two satisfying conditions. Divisibility by 2 and divisible by 3. So, let's try to prove using divisible by 3. So, divisible by 2, whose sum of all digits. So, 5 plus 6 equals 11. Plus 7 equals 18. Plus 4 equals 22. Plus 2 equals 24. Plus 3 equals 27. So, divisible by 2, whose sum is 27. If the 27 is divisible by 2, so it is not. Thus, if the given number is not divisible by 2, there is no need to check using divisible for 3. So, therefore, 567,423 is not divisible by 6. Okay, class, let us discuss the divisibility rule for 7. It is a number we are getting twice the last digit and subtract it from the remaining number in a given number. Result must be divisible by 7. You can again apply this to check for divisibility test of 7. For example, we have 343. So first, let us determine what is the last digit. So the last digit in the given number is 3. So last digit number is 3. So what we are going to do is to express by its definition of the divisibility rule for 7. Again, we are going to twice the last digit. So what is the twice of last digit? Okay, so we have 6. So 3 times 2 is 6. So we put 6 there. And then the remaining digits would be your second hand. So we should express into 34 what is 34 minus 6? So the answer is 28. Is that 28 is divisible by 7? Of course, yes. Therefore, 343 is divisible by 7. Next example, 40,327. So again, let us identify the last digit of the given number. So what is the last digit? Okay, so the answer is 7. So 7 times 2 is equal to 14. So what are we going to do? So you can be express it directly. So the remaining digit of, first we have to rewrite the remaining digits, 4,032 minus twice the digits, the underline that is 14. So what is the difference between 4,032 and 14? So the answer is 4,018. So we have the difference between two numbers is 4,018. Okay, next. So we cannot tell that this result is divisible by 7. So we do it again this repeating process. So 4,018 copy. What is the last digit? The last digit is 8. So get the last digit. So get the remaining digits first. So it becomes 401. Subtracted by, it's the twice of the last digit. So that is 16. What is the difference between 401 and 16? Okay, right. So the answer is 385. So 385, we cannot tell again the result is divisible by 7. So do it again in the same process. So we copy 385. Okay, 385, the last digit is 5. So copy the remaining digits, 38 minus twice the last digit is 10. So what is the difference between 38 and 10? So the answer is 28. So do you think 28 is divisible by 7? Yes. So 28 is divisible by 7. Therefore, this number 40,327 is divisible by 7. Students, let us discuss about the divisibility rule for 8. Divisibility rule for 8, which is a number formed by the last 3 digits in a given number, must be divisible by 8. For example, 234,568. So, what are the last 3 digits in the given number? So the last 3 digits are 5, 6, and 8. So that is 568. So we need to test that the last 3 digits is divisible by 8. So by using the long division process. So we have 568 divided by 8. So we will apply this on the process. So 5 divided by 8 cannot be. So let's add another digit, which is 6. So 56 divided by 8 is 7. 7 times 8 equals 56. So 56 minus 56, which is 0, so no remains. So we bring down another digit, which is 8. 8 divided by 8 is 1. 1 times 8 equals 8. 8 minus 8 equals 0, so no remains. Thus 568 is divisible by 8. Therefore, 234,568 is also divisible by 8. Did you learn it, students? Okay, class. Next divisibility rule, which is 9. This rule is the same as divisibility rule for 3. So, the sum of the digits in the given number must be divisible by 9. For example, 456,786. So, this is the same with the divisible by 3 as well. So since 456,786 is divisible by 9, so we are going to do is to chunk all of these digits. And this is also same procedure to find the sum of all digits. So self-explanatory. So we have 4 plus 5 equals 9. 9 plus 6 equals 15. 15 plus 7 equals 22. 22 plus 8 equals 30. 30 plus 6 equals 36. So, the sum of digits is 36. 36 is divisible by 9. So, this will be doing the same procedure. So, 36 is 3 plus 6 is also equal to 9. Therefore, 9 is divisible with the given number is 456,786. Another example, 87,936. Let us do with the same procedure. Students, what is the sum of all digits is 887,956. So we will do this process. 8 plus 7 equals 15, plus 9 is 24, plus 5 is 29, plus 6 is 35. So 35 is divisible by 9. So we need to test that. So 3 plus 5 equals 8. So this is not divisible by 9. So thus 87,956 is not divisible by 9. Students, the last rule for divisibility, which is 10. This rule which a number which ends with 0. So meaning to say the last digit must be 0. Or it can be easily by skip counting numbers by 10. It can be 10, 20, 30, 40, 50, and so on and so forth. For example, 456,780. So, remember, the last digit must be 0. So, we have to conclude that this number is divisible by 10. How about 74,320? So it is also ends with 0. Thus, this number is also divisible by 10. How about 35,585? What do you think, students? Is that divisible by 10 or not? Students, of course, not, because this number which ends with 5 but not 0. Thus, this number is not divisible by 10. Did you got it, students? I hope also divisibility rules are very useful for determining the numbers in the lesson in arithmetic. So in this video, I hope you appreciate all the learnings that you have in this video. Thank you very much for your watching, and God bless us all.